Good evening. My name is Don Ficken. I'm with the Library Telescope Task Force. A hot evening here in St. Louis, and we're happy to be part of this program. We've been doing this program every month on the Library Telescope for quite a long time. We're building this really great library of videos. You can learn about everything that you could think of. Tonight we'll be talking about 3D printing for the Library Telescope, and I'll talk about that in just a moment. If you're not familiar with the Library Telescope program, it's a program where you can check out a library telescope or binoculars from a library, just like a book. And we're actually building a worldwide map. We have a pretty good penetration now within the United States. Canada is starting to come on in force, and we're also with the Netherlands and the UK getting some involvement in our European area. And so we're really glad to have that. And so we hope that you'll visit our website. If you go to our website, librarytelescope.org, just go under the locations area and you can click and you can find what we know about as far as participating library locations. And if you have a library that you know has the program that's missing off our map, just let us know and we'll make sure and add those to our map. Well, just to mention, we do have a program opportunity for those of you that are participating in the Library Telescope or just want to have a start party. In October 9th through the 16th of this year, you can go to librarytelescope.org and download a flyer, talk to your library about having a start party of some sort, and to talk about the Library Telescope program. We picked that particular week because it's a good time to see the craters on the moon, the Galilean moons of Jupiter, the rings of Saturn. It's just these are really great targets to be able to view through the Library Telescope. You can see in this little brochure right here, we got the rings of Saturn showing very coolly there, and the moon, of course, is just a great target with the Library Telescope. It's almost too bright, actually. It's really kind of cool, though. So this is a list of that's actually for 2022, what we've been doing. Last month, we had a new program launch. We went through a library in California, launched with, forgot exactly, it was 20 some odd telescopes. It's a really amazing launch in a time when it's hard to get telescope. Of course, this month we'll have 3D printing for the Library Telescope. And next month, carrying this theme of how durable is the telescope, we're going to have Mark Stobridge from the New Hampshire Astronomical Society, which that group is actually the ones that founded the Library Telescope program. They've had this Library Telescope program for an operation since 2008. So we want to talk with him a little bit about how the telescope's holding up, what's going on with these things, what do you have to do to repair them. And I think for a library or an amateur club thinking about getting into the program, that between tonight's program on 3D printing of how to do parts and things like that, and this next month, it's a good couple months together, working together to get things started. So with that, I'm going to turn it over to Chuck Sims. I will say Chuck Sims, as he's going to bring up his page for sharing right now. But Chuck Sims actually has been my mentor. I've been learning a little bit about 3D printing, and I just thought this whole thing's fascinating. And this technology of today, it's just wonderful what you can really do to be able to make things really work. And sometimes you just need a part, and you can actually make things. So with that, I'm going to throw over to Chuck. And if you have questions, if you're on Facebook, just post them to the comments area. If you're on Zoom, post them to the chat area or the Q&A area. I will post a link in here very shortly that'll give you some links that Chuck's going to refer to. So just watch for those links in your respective area. So with that, Chuck, I'll turn it over to you.
All right. Thank you, Don. So as Don said, my name's Chuck Sims. I'm with the Astronomical Society of Eastern Missouri. I've been doing 3D printing for a little under 3 years now. And I got into it to begin with is as part of the Library Telescope program. We needed to make parts, and I'll kind of go into that more. But 3D printing on its own it's just a fun hobby, and it can be very useful too, as I'll show you. And what I want to go over with you is just some of the tips that I've learned over the last couple of years in doing this, and just things that you need to know if you want to get into it. So on the agenda, I want to talk a little bit about printers. I want to talk about filaments. That's the material you use to actually print with. If you want to design stuff for the printer, that's a CAD program. We'll talk about that. And then the slicing application software. This is what you need in order to have the print that you want actually communicate with your printer. And then we'll talk about some already created 3D prints for the Library Telescope. But before we get into all that, I wanted to show you just some of the fun stuff that I've made over the last couple of years. And this is just a small piece of it. Just looking here. So this first one is upper corner. This is a I'm forgetting the name of it. It is a flute type instrument that I made. My wife is a music teacher. Um, but it's a flute type instrument with the holes for your fingers. Um, this is a lithophane. This is one of the great things I really like. This, you can take a picture, any picture you want, and there is an online program application you can use to convert that picture into a 3D print. Then you take it into your slicing software we'll talk about later, and actually get, when you print it and you put a light behind it or put it in a window to the sun, you can see that it gets a really good picture. These are absolutely fascinating. And it's just all with the thickness of the print that it gets the different shades. This is a finder scope for a solar scope. So the sun would come through here and shine over here so you can see if your scope is lined up with the sun. And this over here is the beginnings of the solar filter for a 3-inch telescope. You would put a solar film in here, and then this little ring here would fit on top of it, and would just go on the end of a small telescope. I like to play darts. So these are dart holders that I created. This first one here is just flat, and I put, a little sticker on it. And then I said, you know what? What if I actually put the weight, because this is 26 grams, what if I actually put the weight on the holder itself? And so here I put 16 grams embedded into it. So this is kind of neat. This is the little key. If you've ever watched the show Grimm, I love that show. This is one of the keys they have. It actually folds up. This is just a little stand I created. And down here is a picture of my daughter created that's actually on the stand. So I have it sitting in an area where I can see it. Little X-Wing fighter from Star Wars, another little stand that'll hold a globe or a ball. This is a recorder. Like I said, my wife is a music teacher, teaches young kids, so they use recorders. So I thought, let's see if I can make one. And it came in 4 pieces. So I'm showing it separated here, but they just slip into each other. Some Magic the Gathering card cases. So anyone likes to play Magic the Gathering, that's what that is. This is a little D&D character, a halfling rogue. My daughter plays D&D. Guardians of the Galaxy, Baby Groot. And then last but not least, this is actually the very first print I did. It was a test print that came with my printer. So it's just a little puppy, and this is what it should look like, cracks and all. That's it. That is the design of it. So just some fun stuff. I just wanted to kind of show you that. So just as an overview, the telescope that we use in the library telescopes are great scopes, but we've had them, as Don said, since 2008. And I've been involved with the program since 2015 in my library. So 7 years for me, 14 years for some of these other ones. These scopes use more than average telescopes because they're constantly being checked out, constantly being used by different people. And so parts do start to wear out. And what we found is getting replacement parts, eye guards, focuser slips, things like that seem to wear out the quickest are very hard to get. We've been able to get a few, but it's been few and far between. So with 3D printing, we had an opportunity to actually start to design and create some on our own. And this seemed like a really good way to do this. So going into the printers, there are a lot of great 3D printers out on the market. So I will not knock any 3D printer. If you can print on it, it's a good printer. But you got to be careful about what you want as compared to what you're ordering. So you'll see some printers are very cheap. I've seen them as low as $75. I've seen them go into the thousands. And what I found is the less expensive ones tend to be older models, and they also tend to be kits that you put together. So unless you really like spending a lot of time putting it together and getting to know your printer intimately before you get to print anything, I strongly suggest getting one assembled. So just as a story for that, when I bought mine, which is a Creality, that's a picture of it over on the right, a Creality CR20, it was already put together. I think there were 2 screws that I had to put in. My brother bought a very similar model, but it was an older model he bought for half the price. And it was a kit. Literally every piece was separated and he had to put it together. It took him 3 days to put it together. And it was over a month before he printed anything out on it because he just kept having problems and kept having to go back to the company he bought it from. He finally got it. It works great, but it was a very frustrating month to get that going. So I put that out as a warning. With the lower price does come a little more work on your part. There will be maintenance on the printer, so just be prepared for that. 90% of the time, it's usually a nozzle that you're going to replace, and those are pretty straightforward. The nozzles are usually made of brass, so after being heated and having filament go through them, they start to warp a little bit. So replacing them is very easy, or things get clogged up in there and you have to unclog them. But for the most part, they work really, really well. And if you don't want to buy one, there are other options. I've seen some libraries where you can actually check out or use a printer in the library itself. And there are also clubs out there that with a membership fee, you can use them. We have a club by us that for $45 a month, not only can you use their 3D printers and whatever filament they've got there, but they also have woodworking tools, metalworking tool, etching tools, sewing tools, all that comes in there. So basically, if you got a project and 3D printing is part of it, or that's all you want to do, buy a month's worth and just get all of it out instead of buying a printer. And they do the maintenance on them for you. So let's talk about filaments. There are a wide variety of filaments out there. It can be really confusing, but what I found is for the Library Telescope program, there's really only two that I use. The first one is called PLA. It's the polylactic acid. This is the most common filament that anyone uses on the printers. It is this here nice semi-hard plastic that works very well, and I'll show you some of the parts that we created with it. The other one is called TPU. This is a more rubbery material, and I only use that for a few things, and the eye guard is the main one. And just if you can see this on here, this is one of the eye guards, and so it squeezes. It's just like rubber, but it would go right on top of the eyepiece and would keep your eyes, from getting onto the lens itself. You want to make sure you keep them dry. If I can, go over anything on that, keeping your filament free from all the moisture is going to help your prints in the long run. And I'll go into a little bit more about how I did that in a second. And just the most common filament size is the 1.75. I've never used anything else, but I've seen other ones out there. So as you're looking, that's really the one you want to get. So talking about keeping the filaments dry. So what I do is I got a storage container from Home Depot. It's 175 liters, but basically it's just a waterproof one. So no air gets in, no air gets out when it's in there. It holds, I think I've got 10 rolls of filament in there, and it will hold more. Then I use silica gel beads to actually absorb any moisture that's in there. And then I got a humidity meter to measure that. And so as a general rule, it stays about 17–18% humidity in my container, and that seems to be very good. And just as a little story behind this, when I first got the printer, my prints came out really well. She saw the little dog that I printed. But then after probably 3 or 4 months, I noticed that I was having more and more problems with my prints. And I kept clogging up, or they would be going along and all of a sudden they would just fail. And as I did research, it looked like as filaments are just left out, they absorb the moisture in the air and they expand. And so that was the reason it was failing. And so I found a number of different ways for people saying, hey, you make individual containers for each roll, each spool. And I didn't want to go that route. That just looked cumbersome and didn't really look that well for me. So I found this box and, and the silica beads. And I did this, and I would say within having put the old filaments in, when I tried using them a couple months later, they worked just like they were brand new. So you can take old filament, put it in there, it will get that water out of them, and you can use those again. But this seemed like a very inexpensive way to do it. I think the box was like $30. I've seen other ones that were $20, they were smaller. But it's just a nice, easy way to do it and keep them dry. And the silica beads, they're orange, and as they get more and more water, they turn green. So you know when they're getting old, and you just stick them in the oven for a few hours and they come back orange again. So easy way to do it. All right, so let's talk about CAD programs. Love Tinkercad. Tinkercad is it's an online program. You don't download anything to your computer. All your creations are kept out there. It's completely free. And when I first started using it, it was easy to use, but there were some things I just couldn't figure out on my own. And I ran across a tutorial by this gentleman named Eddie Cat. And he just did a fantastic job, created 6 episodes. I think they're like 20 or 30 minutes each. And I watched all 6 of those, and I'm watching him on one screen, doing what he's doing on another screen. And by the time I got through with those, I've never had a problem doing anything in Tinkercad that I want. It was just that good of a program. So this is one of the links we'll have for you, along with the links to the container and the silica gel and monitor meter. So anything I show you out here, we'll have a link for you later on. With Tinkercad, you can create something completely from scratch, or you can import an existing 3D print and modify it, which I've done both of these. And the one thing I will suggest is using a digital caliper. This baby really saved my life. It's like $10. We'll have a link to this too. And when you're measuring something and it's got to be exact, this was the way to do it. And I just want to quickly just bring up Tinkercad just so you guys can see it. So give me 1 second to find that. Should be, oops, that's not what I meant to do. All right, going to make this difficult for me. Sorry about that. You can't see it, but I've got the zoom thing in the way, so I couldn't see this right here. So this is Tinkercad. And as you can see, I've got a finder scope. This is what we call the saddle finder scope in it. And this was created by someone else. I did not create it. But what I did do is I brought it into Tinkercad, and it was round on top. And I believe it was Mr. Don Ficken that suggested, hey, if we had a side on top, as opposed to just the sides right here, and if we go this way, it'll probably be better, because it'll be about even. This is how you would normally look through it. You would look through the holes here, and whatever is at one end, if you get it lined up just right, and I'm having trouble here in Tinkercad, whatever you see in there, you should be able to see in a telescope. Well, we did the same thing with the sights. Sometimes using the sights at the top, the V's, are easier. So added that, and this worked like a champ, and I actually love this model now. So this is Tinkercad. It's just easy. You can see you got all kinds of shapes over at the side. You can move things around. You can make things larger, smaller, duplicated. Like I said, the tutorial is fantastic. I could actually talk, for another 30 minutes just on Tinkercad. I just love this program. All right, moving on, let's talk about the slicing software. So what that does is the slicing software allows you to take either something you created or something you downloaded and make it specific for your printer, which is what your printer needs to do. So I use one called Ultimatic Cura. It came with my program. It's really popular. You could use any slicing software. I'm going to talk about this one only because I use it, I like it, and it just works really well. And what you want to do with Cura is enter things like, hey, what is the printer model that I'm using? What's the filament type and size? What nozzle size? There's a lot of different parameters. Most are standard. Once you put it in there, you say, hey, my printer is a Reality CR20. It's going to stay that way until you tell it different. Same with the filament size. If I say, hey, I'm using PLA and it's at 1.75, it remembers all that. And just want to bring up Cura real quick and just show you what that looks like. So this is that same saddle finder scope brought into Cura. And you can see I can move it around. And once you get it in here and get it the way you want, you slice it. And then over here, it'll tell you things like, hey, this is going to take me 4 hours and 26 minutes to print. If I wanted, I could do a preview on it and just do layer by layer It'll show you, hey, here's exactly how I'm going to build this thing. And it's got 315 layers. So that's how many times the printer is going to go around to build this thing up. So just a great software, easy to export. You can see up here, I'm telling it, hey, I've got a 0.4 millimeter nozzle. My printer is a Creality CR20. There's a number of settings. I'm using standard quality. You can make it just the best quality ever, and it would just slow it down. So just a great little program. Let's see. All right, already created prints. So there are a number of replacement parts that our group has created for the Library Telescope program, and then other ones just friends of ours or friends of the group have done too. And I'll show you those in a second. So we put them we put them all out on a page we call the Hacks and Fixes page. And let me bring that up. So I come over here and I go to Hacks and Fixes. So this page is out on the Library Telescope website. If anyone's on Facebook and doesn't have this, Don can post this link to just our generic out there, or this specific one to Hacks and Fixes. But in it, it's not just 3D files, it's all kinds of stuff. We've got a PowerPoint presentation, but we've got all the instructions for how you want to modify the basic telescopes to make it a library telescope, decals, signs. But when you go down far enough, you get to the 3D files. And here you'll see, here's the saddle finder scope. Here's the tube telescope that we use to replace the 3D or the red dot finders that come on it. We've had one group that needed to get screws, the little screws that actually hold the finder scopes down. They had lost one, so we just created one on the 3D printer. It's easy. The covers for the eyepieces, created those. We got a lot of that here. Here's that one printed out. Actually comes with a hole in it. We put rope to make sure everything stays on. The eye guard, this actually was created by one of our members, the basic design, which is this yellow one down here actually. And what it does is you put it inside the eye relief of the eyepiece. It goes inside here. And it's really for smaller children. Children tend to just kind of look everywhere and they have trouble seeing straight down a telescope eyepiece because it's just so big. And by narrowing their field of view, you force them to look down the center and they actually see things better. So for adults, you wouldn't use this, but this really works well for kids. So created one for the 3D printer and also created the eye guard. Oops, this guy right down here. So you can see I used the TPU on it. You can see I'm fitting it over with a pin on there. So it works great. The visual back. So this is the little piece that goes onto the slip that you would put the eyepiece in. This is one that we found. Someone else had created it. I went ahead and designed another one that had smooth sides, used 3 screws instead of 2, and works really well. Both of which are on our site. And then last but not least on here, I really like this. One of the things I have to do from time to time with the telescope is tighten the nut at the bottom. For some reason, it just loosens up sometimes. And you needed 2 wrenches to do that. So what I did is I made a lock nut that goes on the bottom side and the hex nut goes into it and screw and holds into place. And then I made a knob for the top, as you can see right here. And so if I go out to a library and it's kind of loose, I can just put this knob on there and either tighten it or loosen it, whichever I need. Instead of using 2 wrenches, I just carry this thing with me and it works fantastic. Hopping back over here. Another place to go is called Thingiverse. So if you're just looking for prints in general, and in particular any library prints, you can go to Thingiverse. And I'm going to bring that up here real quick. So this is Thingiverse, and I've actually, if you do a search on library telescope, one word, it'll bring up a lot of the prints that have been uploaded to it. If you just want to see in general what's out there are a lot of stuff. I mean, tens of thousands of prints that you can do, just fun stuff. So highly recommend if you like 3D printing or want to get into it, go to Thingiverse and just take a look around. It's just got a lot of cool stuff. I've liked printing some of the stuff just out there for fun. All right. And there are many other 3D printing sites. I've been to a few of them. I just really like coming back to Thingiverse. As far as I know, I've never seen anything that costs. Some of the other sites do want to charge you for prints. They'll have some for free. I don't think I've seen any that cost on Thingiverse. All right, and just some of the stuff that I've talked about. So here's the visual back, and here it is on the printer. This again is the tube finder along with the saddle finder over here. This is the slip that goes into, this is the original one that came off the library telescope, and this is one that I designed and put on. And I've got the visual back on it already. So this little pinion right here, I'm sorry, the rack here, actually kind of wears out over time. And so just this gives it a new one. This is the little nut that I showed you to hold on the finder scope, little cap, the little knobs, and the CPU eye guard. All right, and these are all the different links that are out there that you can get, all the stuff I've talked about, so you can go directly to it. And Dawn, I believe you put out our 3D printing for library telescope link to everyone. And so those exact same links are out there. So you could go to those at any time.
Yeah, and that's been posted to the Facebook page and also to Zoom. So it's just librarytelescope.org/3D printing, and it'll bring up those links.
And so with that, I'd be more than happy to take any questions.
Well, thank you, Chuck. That's great. I have seen a couple questions. One was from Facebook. Is the Cura program free, and is Tinkercad free?
Both are absolutely free, which is why I love them so much.
Okay, good. They're suggesting that we create a collection on our library telescope program that links to Thingiverse. I guess that's really kind of what you've done already here. It's just a search word. Is that right, Chuck, that you've put in there?
Yeah. Yeah, the search I did is when I upload anything to Thingiverse for the library telescope, I tag it with the word library telescope, one word, no spaces. So if you put that in the search feature, it'll take you to them.
Okay, great. And we have somebody asking about printables.com. Do you know anything about that at all?
I do not know anything about that particular one. There are a lot of great sites out there with different printables on them, different already created prints. So, go out, cruise, take a look at them. I just find that I just like going back to Thingiverse. It just has a lot of good prints.
Okay, so if you have any other questions, oh yeah, here's a question here. What's the main difference between the type of filaments, ABS and PLA?
I'm not familiar with ABS. I know I have seen it, so I can't really tell you what the difference is. A lot of them comes down to hardness. So I know like Pega is a harder plastic than PLA, but it's also a little bit more difficult to print with. ABS, I would probably assume is, the same thing. If you go out and look, you'll find that filaments, there's probably hundreds of different types of filaments, and they're all variations of the same themes. Even with the TPU, you can get TPU on different hardnesses. So you got some that are really soft rubbery, some that are a little bit harder. I think I got mine somewhere in the 80% range. So it was a good hardness, but still flexible enough that you can move things around. So it's one of the things you got to play with. I put links out to the exact stuff that I use just because it's tried and true for me.
So we have an answer from one of our listeners that said, one of our folks on, I think, Zoom here, that ABS is much stronger material, but it's hard to print, requires a heated chamber.
There you go.
And the PETG is a much better option. PLA breaks down under UV and it's brittle. And I think if you have a lot of light, which of course telescopes don't have too much light, but if you have a lot of light, I think PLA might be easier to print. Maybe, I don't know about that.
Yeah, PLA is very easy to print, but you're right. If you've got something that you created with PLA and you stick it outside in the sun, it will start to melt. That's just the way PLA is. It works great for the library telescope program because the telescope is usually two places. It's inside in the day and it's outside at night when there's no sun. So we've never seen any issues with PLA there. But if you're looking for something you want to be outside in the sun, there's a harder materials that are more sustainable.
Right. So for those of you who have created links that you think could help us, just let us know through our librarytelescope.org webpage. Just send us contact us and give us some links to what your material is. And if it's something that we think we can add to our library telescope program that would be useful, we welcome that. And by the way, I did not mention when we first started that our Facebook page, a guy named Tom Lynch, who's not here tonight, has done such a terrific job. And there's a lot of good postings on there. We've got something like 4,000 followers now. So that's a really great place to really to learn more about the Library Telescope program. And we will be posting a video of this particular session probably tomorrow. It's if you go to our librarytelescope.org webpage, go to the YouTube tab at top. We've got an entire library of this stuff. And we got a question here about, would like to talk to someone about sourcing telescopes to the program. Just go to the librarytelescope.org page and hit a contact us, and we'll be happy to reach out to you. Yeah. So we have a question here from a viewer. Any ideas for putting tamper-resistant caps or standard factory provided collimation screws so we don't have to modify the mirror cell? In other words, some way to protect the mirror so that we can not have to completely modify it, maybe make something with the 3D print to get put over it or whatever else. Have you thought about that, Chuck?
I was going to say, within our group, we have discussed that, and whether we want to 3D print it or get something else. We have talked about getting a plastic cover that goes over the back and would screw into the side, but nothing concrete on that. There are lots of different options, but I don't know if doing that is the best one or not. So yeah, still discussing. So we designed nothing for it at this point.
So I think we welcome ideas, and we do have a little fun. It does sometimes gets a little frustrating because you can see the print hours. You have to sometimes print a low quality, and it still might take 6 or 8 hours. And also just the print capacity, in other words, the size of your printer, how much it can actually do. Sometimes you have to break the thing up into pieces, but we welcome any suggestions you guys might have about basically 3D printing or telescopes, or if you want us to learn more about the Library Telescope program, go to our telescope.org website, or Facebook is a great area too. There's a lot of people out there putting a lot of great ideas out there. All right, Chuck, I think we're about out of time here, so we will post this. Do you have any other comments, Chuck, before we wrap up here?
Not really. Just want to thank everyone for being here. I really enjoyed talking to you guys, and maybe we can do another follow-up on this later on and go into more detail on any one area.
Yeah, this has been a lot of fun, and Chuck has got me, he teased me into it, and I finally actually purchased a 3D printer, and he actually gave me all the working steps, and I've had almost no problems with it. I mean, I've had a couple of things where I messed up and I said, oh my goodness, but then I really figured out how to get past it. But Chuck's been a great resource. And I think if you join us next month on August 17th, you're going to find a little bit about from Mark Stobridge, how we've managed to make these telescopes continue working. And that's true in St. Louis, and we have something like 40 clubs that get together on a regular basis in our Library Telescope Task Force. So if you're interested in joining that task force, if you're an amateur astronomer or library, just want to learn more, just contact us, and we'll try to help you out there. So Chuck, thanks for a great program tonight. Once again, this will be recorded. This is being recorded. Of course, it'll be on Facebook already, but we'll get that out to our YouTube page in the next day or so. So thanks, Chuck, and everybody have a great evening, and thank you for joining us.